Let me show you how to better dimension complex profiles in ArchiCAD. When creating documentation drawings, it is important to ensure the information indicated on the drawing is always the latest. So as usual, live automated labels are the key. ArchiCAD has a good library of labels that can automatically dimension and indicate details of certain building elements such as walls, slabs, and complex profiles, as you can see from this example. By using a dimension label, I can quickly show the information embedded in the complex profile, in this case, a roof parapet that I have created. But as you can see from the video, the label only indicates the overall sizes, which is useful to a certain extent. However, there are other ways of showing more detailed information about a particular build-up. The beauty of ArchiCAD complex profile is that you can draw every component forming part of the building element in section and then use the cross-sectional profile to model actual construction elements in the project. A sometimes overlooked tool that is so powerful and effective for equally creating and modifying 3D elements in the ArchiCAD model. To exemplify how to make best of the ArchiCAD labels, I have created a simple roof parapet with stone coping which has brick facing cladding and an RC wall as an inner skin. If I would like to annotate on plan or in section or in the 3D document the size of this parapet using the inbuilt dimension label, I would be limited to the overall width, height, depth of the complex profile. This is useful if the overall dimensions change, but when the changes are not that apparent, the overall dimension is going to give you the same reading even if the parapet has been fundamentally changed. Therefore, using the autotext label instead, I can show the dimension of any elements comprised in this complex profile. To only dimension an element that is part of the roof parapet, I need to pick a label that can read the information from within a complex profile. So in this example, I will use the simple autotext label as this covers a great deal of information that is built within the elements of the project. Therefore, if I want to dimension the constituent parts of the parapet, such as the brick skin, the RC wall, and the stone coping, I will need to go back a step and add what is called a profile modifier, aka offset modifier. To do that, I need to open the complex profile and create a custom modifier, which I'm going to call it RC height, and press OK. Then I need to define the dimension of that element. By the way, you can create as many modifiers as you require. For example, I can create a brick height modifier as well, since it's very easy to do it. You just select the outline or the outer points and drag the height dimensions to the side. If something is not correctly linked to the 2D elements, or if the modifier is not snapping to the elements the way it should, like the RC width modifier here, then you're going to get an error that the modifier you have just created won't be available. So always make sure that your modifiers are snapping to the object you want to dimension. I will also create a width modifier, so I can dimension the cavity width. This is just a blank space between the two skins, but as long as I snap to the either side lines, then I'm going to get a proper working dimension. All I need to do next is save the changes, then go back on plan, select the autotext label, and then click on my parapet. Next, I need to choose the modifiers I have just created from the drop-down list and click outside the label. As you can see here, the autotext is going to give you the value only, which is the RC height, but it's not going to give you the description of the value, i.e. RC height and cavity width in this case. If you want to know what it is, you can add plain text description as part of your auto text, i.e. cavity width and RC height. The advantage of going for the auto text label to dimension the complex profile is that in the situation where the parapet changes, such as the RC wall increases in height or the cavity width modifies, you will see that the dimension is also automatically updated, which is of tremendous help when working with an ever-changing model or an evolving design. This way, there is no need to remember to manually change the size information every time the model changes, as your labels are going to keep up the pace and always read the current status of the elements within the architectural model. You will instantly see the change in plan and have your documentation drawings up to date in an instant. Thank me later.